Hello, very good evening to all. My voice is audible to all of you? Yes, please confirm once and after we start our today class, right? मेरी आवाज सबको आ रही है ना? Good, good, good. Okay, yes. So just want to know from you, uh, currently in your school, which chapter is going on? Means which chapter you completed? Because in Saturday and Sunday class now, I'm going to try to, give you a numerical and give you a clarity of the numerical portion, right? So we are going to solve more and more numerical so that तुम लोगों का concept अच्छे से strong होगा. इसीलिए मुझे just जानना है कि अभी आप लोगों के जो schools हैं उसमें कौन सा chapters हो गया है. बिकॉज फ्रॉम द स्प्लिट ऑफ सिलेबस आई केम टू नो कि अभी आप लोग का हेलोजन या अल्कोहल चैप्टर होना था. सो जस्ट कंफर्म वंस एंड आफ्टर दैट वी स्टार्ट आवर सेशन, राइट? सो विच चैप्टर इज गोइंग ऑन इन स्कूल राइट नाउ, और यू जस्ट कंप्लीटेड विच चैप्टर? कैन एनीवन टेल मी? Anyone want to share which chapter is currently going on in school? Chalo. So, according to the split of syllabus, basically, alkyl halide, aryl halide, or alcohol, these chapters supposed to be, from the May of the last month of the July. Okay. So, we are going to solve numerical related to this chapter. So, before starting the problem solving, let's quickly revise this chapter. So, in today class, I'm going to explain you all the concept of this chapter, that is organic compound containing halogen, or we say alkyl halide. Okay, so in today class I'm going to explain you and or revise you all the important concept of this chapter and try to solve some numerical also. Or in the next class, that is Sunday, for tomorrow, we are entirely dedicate this class for the problem solving. Okay, so let's quickly start. So whenever you find any difficulties in identify or in anything, you can ask me. Okay, I'm here to reply you. Okay, so first of all, if I'm talking about the alkyl halide, so we all know now what is alkyl halide, right? Because we know that in CH4, that is alkane. So if we replace one H with the halogen, right? If we replace one H and add one chlorine, then it will become what beta? Then it will become CH3Cl, right? So what is alkyl halide? So alkyl halide is nothing but when the halogen, right? When the halogen replaces one hydrogen of the alkane, it will become alkyl halide, or they also known as a haloalkane, right? So these are the basically alkyl halide what we have. So how will you prepare alkyl halide? So this is the most important question. So if you want to prepare alkyl halide, how will you prepare this alkyl halide? Okay. So the first method for the preparation of alkyl halide is, that is alcohol. Okay. So this is the first way, but this is a better way also for the preparation of alkyl halide, right? So first method that we are going to discuss is alcohol. So from alcohol, how will you prepare? So we know that whenever we treat alcohol with px3, what do you mean by this X? Where this X is either chlorine or bromine, right? So when we treat alcohol with the PCl3 or PBr3, then RCl or RBr will be formed. For example, let's see the example for this. For example, if we treat alcohol, that is ROH, with the PCl2, SOCl2, so from PCl5, PCl3, SOCl2, all will get this, right? So I hope ये सबको समझ आया होगा. How will you prepare alkyl halide from the alcohol? So just simple way, by treating, that is, this is nothing but alcohol, right? So when you treat alcohol by either of these reagents, either it will be PCl5, either it will be PCl3, either it will be SOCl2, right? So in all these three, or we can also say that it will be either like can we say that like P plus I2. So this also give the alkyl halides, right? So in all this we'll get alkyl halide, that is RCl, RCl, RCl. If we'll take X as a, right, a halogen as a RCl, right? So out of these four methods, if someone asks which one is the better one, right? Because all four methods, PCl5, PCl3 or SOCl2 or P plus I2, we prepare RCl. But out of these four, which method is more important? Which method is good the amount in a good yield, right? So always remember this, that is the treating with the thionyl chloride, that is SOCl2. This one is a very, very, very important method. And in this way, we get the maximum out of RCl, or we'll get the, this is the best method for the preparation of alkyl halide. Right. So if you want to prepare alkyl halide from alcohol, these all methods are okay. But out of these, which method is the best one? So always remember, beta, best method is SOCl2. ठीक है, सबको याद रखना है, SOCl2 is the best method. Now, if someone asks why this is the best method, can you explain why this is the best method? Because in this, RCl is formed, along with this, HCl plus SO2 is formed. So we know that SO2 is gas, so it will evaporate out easily. HCl is also in a gas form, so it's also evaporate out easily. So here we can easily, get RCl. So there is no need to separate, further things. Like in this RCl, in PCl5, we'll get POCl3 like this thing, and also HCl. So in this thing, along with RCl, we also have a POCl3. So we have to separate this thing. So separation become difficult, right? But in SOCl2, SO2 is formed and HCl is formed, and both are in gaseous form. So they easily evaporate. So we can say that this method is the best way. सबको समझ आ गया? एक बार जल्दी से बता दो. Anyone having any kind of doubt? किसी को कोई भी प्रॉब्लम हो पूछो जल्दी फटाफट. और अगर समझ आ गया है तो जस्ट एक बार बता दो मेरे को, so that हम आगे बढ़े. क्लियर है सबको? Is it clear to everyone? I'm waiting for your responses. Tell me fast. सबको समझ आया? Everyone? सबको अंडरस्टूड है? राइट, JNV गोंडिया, राइट, ओके. सो बाकी सबका क्या है भाई? बाकी सब भी फास्ट? एनी डाउट टिल यहाँ तक? कोई भी डाउट हो तो बताओ मेरे को. नहीं है? ठीक है. सो दिस इज वन ऑफ द बेस्ट मेथड फॉर द प्रिपरेशन ऑफ द alkyl halide by using alcohol, right? So this is very, very important method, and always remember this. How will you prepare from this? Okay, sure. Next. So next method is that is the halogenation of the hydrocarbon. So this is also a very important method, right? If I'm talking about the halogenation of hydrocarbon, so this is also a very, very important method for the preparation of what? For the preparation of alkyl halide, right? So how will you understand this? So let's see an example, right? So we'll understand by looking at this problem. For example, if we take CH4, right? If we take CH4 and someone says, write the reaction of CH4 with the Cl2 in presence of sunlight, right? In presence of sunlight. So this is a hydrocarbon alkane, right? And this is the Cl2 in presence of sunlight. So what will form, beta? That is CH3Cl plus HCl, right? So this CH3Cl will be formed. Okay. So one important note here, this alkyl halide is very, very, very reactive, right? This alkyl halide is very reactive, and this reaction does not stop at this level. They further react with the Cl2 to form CH2Cl2. Again, they react with the Cl2 to form CHCl3, that is chloroform. And again, they react to form CCl4. So this method is not very much useful, because in this we cannot get the pure methyl chloride, right? Because the reaction is very, alkyl halide is very reactive in nature, and they continuously react with the Cl2 to form CH2Cl, CHCl3, and later CCl4. But if, when you treat CH4 with Cl2, in the limited supply of Cl2, or we say excess supply of CH4, then methyl chloride will be formed, right? So this is the one way for the preparation of alkyl halide. So on the similar basis, just like chloromethyl, right? Chloromethyl, we can prepare bromomethyl as well, right? So bromomethane we also prepare. For example, if you treat CH4 plus like Br2, same case, in presence of sunlight, you can also prepare like CH3 and Br. So chloromethyl and this is a bromomethyl, both are prepared by this method, right? So this is the method from the hydrocarbon. So here we can say that this is a RH and this react with X2. This X2 either it will be chlorine or bromine. Only chlorine and bromine, always remember this, not fluorine and iodine. For fluorine and iodine, I'm going to discuss some special method, because why fluorine and iodine cannot be prepared as method, there is a reason behind this, right? So I'm going to share with you that why the bromine iodination and the fluorination cannot be takes place, why chlorination and bromination will take place, right? So before this, let's see one example of the chlorination once more. So this is the tertiary alkane, as we can see that. So this is a 1 to 3 degree carbon we have, and this react with the Cl2 in the presence of heat or light. So we know that this is a tertiary carbon do not have any H. So if the chlorination will take place either with this carbon atom, right, or we can see that. So this chlorination will be formed, right? Again, when this is react with the CH3, CH3, CH, this is a secondary. So one H is there now, right? So one H is there. So in this two product will be possible. Either this that is a CH2Cl and either this. So out of this, which product is in major and which product is in minor? So always remember this product, that is this one, this is always formed in a major, where this is formed in the minor. Always remember this thing. So just like a bromine, they are also the minor and they are the major product. So this is happened in the case of fluorine and bromine. Now I'm going to explain you why. Let me take one sheet for this. Right. So let me take one important sheet. Sure. So why iodination and fluorination one takes place, right? Because many times questions were directly coming that why fluorination and iodination of haloalkane cannot take place. Why? What is the reason behind it? So, for example, if I'm talking about the iodination, right? Iodination. So, if I'm talking about the iodination, we know that how iodination will be happen, beta. So iodination is nothing, just like the chlorination and bromination. When you treat CH4 with the I2, right? Then what will form beta? It will form CH3I plus HI, right? So तुम्हें तो लग रहा है कि तो बन गया, तो क्यों नहीं बन रहा है? वहां तो आप कह रहे हो नहीं बनेगा. But one important note here, this reaction become reversible, right? This reaction become reversible. So this is the big issue. Why this reaction become reversible? Why this is happening, right? So when we treat CH4 plus I2, CH3I form, this will be fine. Okay, we want to prepare this idomethane. But with the idomethane, HI is also formed. And this HI is highly reducing in nature. So they are reducing nature. They are in reducing nature. And due to this only, reducing nature, and due to this only, due to this only, due to this only, the reaction, the reaction become reversible. Okay, so they are reducing in nature, and due to this only the reaction become reversible in nature. So due to the formation of this HI, the reaction is reversible. So if the reaction is reversible, then what is the use of producing CS3I? Because they immediately combine with HI to give back the CH4 plus I2. Right, they can easily give back CH4 plus I2. So this is not the way for the preparation of CH3I. So what we'll have to do? What we have to do better for this? If we want to prepare for this, then what we have to do? So for this, what we need to do better? We have to add an oxidizing agent, right? So we have to add an oxidizing agent. Why better? Why we have to add an oxidizing agent? right? So reversibility is due to what? Can anyone tell me? So reversibility is due to the formation of HI, right? So reversibility is only due to formation of HI. So what we have to do? What we have to do? So we have to add an oxidizing agent, right? So the solution is we have to add we have to add an oxidizing agent. So we have to add an oxidizing agent, right? So we have to add an oxidizing agent to make to make this reaction irreversible, right? So can you tell me the example of oxidizing agent that you know? That is HiO3, right? That is HiO3. So these are the oxidizing agent, that is HiO3. So we have to add an oxidizing agent called HiO3. Okay. So this is an oxidizing agent that we need to add. So what this oxidizing agent do? So basically this oxidizing agent, that is HiO3, they react with Hi, right? They react with Hi to form I2 plus water, right? They form I2 plus water. Now the formation of HI is minimized, right? Now there is no formation of HI. So as soon as we add HiO3 to this reaction, this HiO3 convert this HI to I2 and H2O, and the formation of HI is minimized, or we say stop. So if HI is not formed, right? So if the HI is not formed, then definitely this reaction won't become reversible, because HI is the reason for the reaction to be reversible. If we by anyhow we minimize this HI, we just neglect, if you neglect the effect of this HI, then we can say that this reaction become irreversible in nature. Hmm? So this is what we have to do for this, right? So this HiO3 react with HI to form I2 and plus H2. I hope this is clear to all of you. Clear है? सबको समझ आया क्या यहाँ तक? What is the role of HiO3? Why we add HiO3 to this reaction, and why iodination cannot take place just like chlorination and bromination? Can you get the answer for this question? Why iodination cannot be prepared just like halogenation, just like a chlorination and bromination? Hmm? Chalo. So this is what happening in the case of iodination. Always remember this thing, right? Okay. So for iodination, we have some special method like the Finkelstein method that we are going to discuss in a later class. That is, we have a Finkelstein method also where we can prepare iodination, right? How will you prepare this beta? So this one is the important method. So important method for the preparation of hydroalkane. Right. So which one is the important method for the preparation of hydroalkane beta? That is the Finkelstein method. Always remember this. This is a nothing but Finkelstein, Finkelstein reaction. Clear? Eh? So this is called the Finkelstein reaction. So what is this reaction all about? So in this reaction, basically, when we treat CH3Cl plus, right, CH3Cl, and this is react with NaI, NaI in presence of acetone. In presence of acetone, right? So when you treat CH3Cl, that is a methyl chloride with the NaI in presence of acetone, what will form beta? That this NaCl will be formed. So this NaCl will be removed, NaCl, and what will form beta? That is CH3I. So this is the method for the preparation of iodobenzene. So this is the special method for the preparation of iodoalkane, also known as the Finkelstein method, right? So always remember this. So this is one of the important method for the preparation of the iodoalkane, also known as the Finkelstein reaction. I hope this is clear to you. Chalo. So this is the method. Okay, so many of you have one doubt related to this Finkelstein reaction. That is, why only NaI is taken, right? Can you take NaCl instead of NaI, or we take NaBr instead of NaI, right? So why only sodium iodide is taken? So always remember this, because only NaI, that is sodium iodide, is soluble in acetone. Right. So this is a very important fact, that why we take only NaI, and why we know we won't take NaCl or NaBr here, because only NaI, because only NaI, because only NaI are soluble, soluble in acetone. ठीक है? So because only NaI are soluble in acetone, not NaCl or NaBr, we only take NaI for this reaction. Right? So सबको clear है यहाँ तक? किसी को कोई भी doubt हो तो please you can ask बेटा, related to anything related to iodination. That why iodination cannot be takes place just like chlorination. Why we have to add an oxidizing agent. Why the reaction become reversible because the formation of HI. What we need to do to make this reaction irreversible. What happen when HiO3 react with HI. So all of these question I hope you'll get the answer, right? So सबको इसका आंसर मिल गया है सभी क्वेश्चंस का, जो भी डाउट था. And the special method for the preparation of iodine is none but Finkelstein reaction, right? And why only NaI and NaI is taken? Because only NaI is soluble in acetone, not NaCl and NaBr. So I hope this is clear to all of you. जल्दी बता दो एक बार फटाफट. Yes. फास्ट. सबको क्लियर है? समझ पाया सबको कैसे बना ये? JNB गोंडिया, JNB सिमोगा and JNB कोल्हापुर. Anyone having any kind of doubt till you can ask, or we proceed to the next if all clear, right? Chalo. So this is a very important thing. Okay. I hope you all take the screenshot of this. The next is, or you note it down, you know. The next is fluorination. Fluorination. So just like chlorination and bromination, fluorination won't be possible. Why? Why when the CH4 react with F2, why they will not form CH3, right? So the reaction become explosive. Always remember. Right? So the reaction become explosive. So always remember that whenever the CH4, right? Whenever the CH4 react with F2, the reaction become explosive in nature, right? They are very explosive, and the container in which we carry out this reaction, the container may be, break. This reaction is very explosive and liberate large amount of heat. So fluorination of methane won't be possible, or with alkane won't be possible due to the explosive nature of this reaction. So what we have to do, is there any special method for the preparation of fluorine? Yes, so we have one very special method for the preparation of alkyl fluoride, and this method is nothing but known as Schwartz reaction, right? So the method is Schwartz reaction. ठीक है, Schwarz reaction. So क्या होता है ये Schwarz reaction? What is this Schwarz reaction basically? So Schwarz reaction is also known as halogen exchange method. So it is also known as halogen exchange method. ठीक है, so it is also known as halogen exchange method. Okay, what is the reaction for this reaction? That is when we treat CH3Br with any metallic fluoride, right? With any metallic fluoride, either it will be the silver fluoride or the mercury fluoride. So you can take any metallic fluoride. Let's say we are taking AgF. ठीक है, so what will form? So it will form again CH3F plus AgBr plus AgBr. So here we can say that na exchange of halogen will be takes place, like fluorine from AgF will go to the CH3 and bromine from CH3 will go to the Ag. So we can say that the halogen exchange will also takes place, right? So halogen exchange is also takes place. That's why it is also known as halogen exchange method, right? That's why they are also known as halogen exchange method. Okay. So this is the Schwarz reaction. If someone asks what is Schwarz reaction, then you can easily say beta, that is the formation of CH3CF when we treat alkyl halide with the AgF, metallic fluoride. So basically, one question that is coming in the JEE exam, that is JEE main exam. JEE main exam, they are asking the synthesis of alkyl fluoride is best accomplished by. So what is the best way for preparation of alkyl fluoride? The first option is Finkelstein. The second option is Schwarz reaction. The third option is free radical fluoridation. And the fourth one is Sandmeyer reaction. So which method is the best for the preparation of alkyl fluoride? Methyl fluoride better. Can anyone say? Methyl or alkyl, you can say anything. Both are same. So which one is the best method for the preparation of alkyl fluoride? Finkelstein, Schwarz reaction, free radical, or Sandmeyer? Obvious beta Schwarz reaction, right? So Schwarz reaction is the best method for the preparation of CH3F, or we say alkyl fluoride. Anyone beta having any kind of doubt, you can ask फटाफट जल्दी पूछो, किसी को कोई भी डाउट हो अभी तक? Yes, किसी को कोई भी डाउट है अभी तक? Tell, related to Schwarz reaction or fluorination. No, clear है? चलो. So this is the method. So from from the hydrocarbon, that is from the alkane part, we came to know we have a four-way for the preparation of alkyl halide. The first one is a chlorine. So when we treat chlorine with the hydrocarbon, that is alkane, will get the chlorination. But what is the disadvantage of this reaction? The reaction become, this reaction is very, very reactive and the reaction is continuously taking place until carbon tetrachloride will form, right? Now, the next one, just like a chlorination, bromination is also there. But if you want to prepare iodination and fluorination, then we have to, use some other method, some special method, right? For iodination, we use Finkelstein method because in iodination HiO3 is formed, which makes the reaction reversible. And similarly, in the fluorination, the reaction become explosive on treatment with CH4 plus F2. So we need to adopt some different method like a Schwarz reaction. So we use Schwarz reaction because in Schwarz reaction, what happened? When we treat alkyl halide with the metallic fluoride, that is HEF, halogen exchange will be takes place and CH3F, that is alkyl fluoride, will be formed. So this is all about the Schwarz reaction. I hope this is clear to you. चलो, so दो मेथड हम लोगों ने कर लिया. अब third method है, that is a side chain halogenation, or we can say alkyl benzene, right? Or we can say alkyl benzene. So let's see side chain halogenation. What is this side chain halogenation basically? So when we treat toluene, hmm, this is the nothing but toluene, and when they react with X2 in presence of sunlight, this X2 either become Cl or Br. It will is anything. So when we treat with this CH3 toluene with the X2 in the presence of some sunlight, it will form benzyl halide, right? If they will form CH2Cl, we can say that benzyl chloride. If it will form CH2Br, we can called benzyl bromide, right? So when we treat toluene with the X2 and S presence of sunlight, they will form benzoyl halide. Similarly, when we treat the CH3 in the presence of excess of halogen, that is 2X2, so it will form CH or X2, or we say benzyl halide, right? Because in this, we have a two halogen group attached to this because halogen are taken in excess. So we get the benzyl halide. Similarly, if we treat with the 3X2, we will get benzo trihalide and benzo trihalide, just like CCl4 we have. So just like in this, we have a CCl3. So there is no H remaining. So this reaction cannot be takes place further. So it will stop at the benzo trihalide, right? So this is a benzo trihalide. Now, when we treat with the bromine in the presence of HNO, what will form? That is, this will form CH2 and Cl. So this point is more reactive now. So this will form CHBr and CH3. That is one bromo, one phenyl. This is the only product that we have. Right. So this is the side chain halogenation of alkyl benzene. So we can also say that this is the method of preparation of alkyl benzene. Okay. Now, this is the addition of halogen halide to the alkenes. So what happened when the halogen halide is treated with the alkene? So let's see the addition of halogen to alkene and both alkyne. Both we are going to see, that is alkene and alkyne. So when we take a symmetrical, we can say that this is a symmetrical alkene we have. And when we treat with the X2, that is any halogen, chlorine or bromine, so what we'll get, we'll call vicinal dihalide. What is this vicinal dihalide, beta? When we get the two halogen atom at the two adjacent carbon atom, then it will say that this is a vicinal dihalide. So what do you mean by this term vicinal dihalide? That is the two different halogen at the two adjacent, or we say, so sorry, we can say when the halogen atom are attached to the two adjacent carbon, then they are said to be vicinal dihalide. So this is the formation of vicinal dihalide. Similarly, in the alkyne, we are treating with the 2X2, so we'll get the same thing, right? Now, this thing we already studied. That is what happened when the reaction with the phosphorus halide. That is what happening when the alcohol is treated with the PCl5, PCl3, and PBr3. We already studied this thing, right? That is, whenever the ethanol is treated with PCl3 or PCl5 or PBr3, we'll get alkyl halide plus H3PO3. So out of this, which method is correct, beta? Which method is very much good? That is this one, right? That is with thionyl chloride. So thionyl chloride, that is SOCl2, is the another reason which react with alcohol to give a chloroalkane. Both of the byproduct SO2 and HCl are gaseous. Therefore, the purification of the final products is not required. And we already discussed this, right? So no need to bother. Okay, the next thing is from the aromatic hydrocarbon. So how will you prepare haloarene? So now we are going to see the preparation of haloarenes, right? So how will you prepare haloarenes, beta? So we can prepare haloarene from the aromatic carbon. That is, haloarenes are obtained by the direct halogenation of aromatic hydrocarbon in the presence of a catalyst, usually iron filling or iron halide used as the catalyst, right? For example, when you treat benzene with the X2, this X2, what is this X2? This X2 either will be Cl or Br. So when we treat this benzene with the X2 in the presence of FeCl3, right? In the presence of FeCl3, then what will form? They will form chlorobenzene. For example, let's see when you treat this benzene, okay? So this is the benzene for you. And when you treat with the Cl2 in presence of is very important, that is Fe or FeCl3. So what will form, beta? Right. So chlorobenzene will be formed. So formation of chlorobenzene will be takes place. So the chlorobenzene will be formed. Similar, just like in idoalkane, so reversibility problem is there. So in this also, the direct iodination of aromatic hydrocarbon is not useful reaction, since the HI produced reduces the aryl iodide back to the aromatic hydrocarbon. So for this reaction, we need to add an oxidizing agent like HiO3, so that they can convert this Hi into H2O plus I2 and the reaction become irreversible. Okay. So direct iodination of the aromatic hydrocarbon is not possible, just like a aliphatic iodination. Here we can say that also this benzene react with I2 and the reaction become reversible. So what is the reason for the reversibility of the reaction? We already know this thing. This reaction is reversible because of the formation of Hi. This Hi make this reaction reversible. However, in the presence of an oxidizing agent such as a nitric acid or iodic acid, or we say mercuric oxide, right? The HI produced is either oxidized to iodine or is eliminated as a mercuric iodide, and thus iodobenzene is obtained. So the main problem, that is HI, they will now convert into I2 plus H2O, so we can get easily iodobenzene. Chalo. The next thing, this one is very important, that is from disonium salt. So how will you prepare from the disonium salt, right? So what we want to prepare? We want to prepare the aromatic halide, that is either chloro, bromo, fluoro, or iodobenzene. So the method is from the disonium salt. So what is this disonium salt, beta? Basically, the disonium salt is formed by treating an aromatic primary amine with the NaNO2 and dilute HCl at the low temperature. Then this process is known as disonation. We are going to study this chapter in the our chapter coming chapter, that is amine. Okay. So this is the disonation through which you will prepare benzene disonium chloride. But in this method, we are going to see how will you prepare alkyl halide by disonium. क्लियर है सबको? जल्दी बताओ मेरे को एक बार, यहाँ तक किसी को कोई भी डाउट हो, एनी टाइप ऑफ डाउट, कुछ भी हो, जल्दी बताओ मेरे को फटाफट. आई एम वेटिंग फॉर योर रिप्लाई. फ्रॉम डाइजोनियम सॉल्ट, एंड डाइजोनियम सॉल्ट से कैसे बना बीडीसी, यहाँ तक कुछ भी डाउट हो पूछो. नो, किसी को डाउट नहीं है? ठीक है सबको? चलो. सो दिस इज फ्रॉम द डाइजोनियम सॉल्ट, दैट इज अ बेंजीन डाइजोनियम सॉल्ट. ये बन गया हमारा, राइट? दिस इज कॉल्ड बीडीसी, N2Cl. Okay, so this is the BDC. So disonium salt are highly reactive compound. Always remember this. Disonium salt are highly reactive compound, and they are used in the preparation of large number of arene derivative. Right. When a disonium salt is treated with the copper chloride, that is Cu2Cl2, or a copper 1 bromide, that is Cu2Br2, the corresponding haloarene is formed. For example, when treated with the copper chloride, then obviously chlorobenzene will be formed, and we treat with the copper bromide, then obviously the bromobenzene will be formed. This reaction is also known as a Sandmeyer reaction, and it is used for introducing a chloro or a bromo group in the benzene group, right? So if you want to introduce a chloro or a bromo group in the benzene ring, then you can use this method, that is a disonation, right? So here we can see that this is the BDC, right? This is the BDC, that is benzene, dizo, that is NN, disonium, and chloride. So when you treat benzene disonium chloride with the copper Cl and HCl, here what do you take on? Copper Cl, always remember. So when we treat with the copper Cl and HCl, chlorobenzene will be formed. Similarly, when you treat with the copper Br and HBr, bromobenzene will form. When we treat with the Ki, or we just warm the solution, then it will become iodobenzene. Similarly, when you treat with the NaNO2 and HBr4, it will become fluorobenzene. This is also known as a Blass-Sachs reaction. Blass-Sachs reaction. So this is also known as a Blass-Sachs reaction, right? So I hope this is clear to you. So we have a total how many method? 4 method. When you treat copper chloride plus HCl, then we'll get chlorobenzene. Similarly, copper bromide will get bromobenzene. And will treat with the Ki will get idobenzene, and treat with the NH3 for blast achievement reaction of fluorobenzene. Right. So this is how will you get this. Now, this reaction is called this Sandmeyer reaction. Sandmeyer reactions, right? So whenever the BDC is treated with the copper chloride or HCl, right? Whenever the BDC is treated with the copper chloride or HCl, we can say that this method is become Sandmeyer reaction. But when this BDC is treated with the only copper plus HCl, not copper chloride, always remember this. Here we have a copper chloride plus HCl, right? In this first two cases, we have copper chloride and HCl. So when this BDC is treated with the copper chloride and HCl, they will form also chlorobenzene. Now when they are known as Sandmeyer reaction. Now when they treated with the copper plus HCl, only copper, and copper plus HBr, then they also form chloro or a bromobenzene. But this reaction become a Guttermann's reaction, right? So haloarenes can also be prepared by reacting benzene diammonium chloride with the copper powder in presence of corresponding halogen acid. So this reaction is called Guttermann reaction, as we can see here, right? So these two reaction is known as Guttermann reaction. Guttermann reaction. Okay. So this reaction is also become known as Guttermann reaction. So I hope सबको clear है. Okay. Now, so we are done with all the method of preparation. So we already studied the method of preparation of alkane, and now we already also studied the method of preparation of aromatic alkyl halide. Right? That is how will you prepare Sandmeyer reaction, Blass-Achievement reaction, and the Guttermann reaction. So this reaction we already completed. Now, let's see the properties of haloalkanes and haloarenes. So we are going to see the physical and the chemical properties of the haloarenes and haloarenes. So first of all, the nature of CX bond in alkyl halide, that is the carbon halogen bond, is formed by the overlap of sp3 hybrid orbital of carbon atom with the p orbital of the halogen atom, right? So the nature of CX bond in alkyl halide, always remember the nature of CX bond in alkyl halide. CX bond in alkyl halide, the carbon hydrogen bond is formed by the overlap of the sp3 hybrid orbital, right? So whenever in the CX, that is the carbon halogen bond, this will be formed by the overlap of sp3 hybrid orbital of carbon atom with the p orbital of the halogen atom, right? Now, as one moves from fluorine to iodine, as we move from fluorine to iodine in the periodic table, the size of the halogen atom increases. We all know that whenever we move down from top to bottom, number of shell increase, or we say size definitely going to increase, and hence the overlap tendency become decreasing. Hence the CX bond becomes longer and weaker on going from alkyl fluoride to alkyl iodide. So if someone asks out of alkyl halide and out of alkyl fluoride and alkyl iodide, which one is more reactive? So definitely, alkyl iodide, as we move from left to down the group, overlapping become weaker. CX bond become longer and overlapping become weaker on going from alkyl fluoride to alkyl iodide. So we can say that alkyl iodide are more reactive than the alkyl fluoride. Okay. Now also the halogen are more electronegative than carbon atom. They always tendency to get the electron from the carbon. So thus the electron density along the CX bond is displaced in the direction of halogen. Thus we can say that the CX bond in the plane is polar in nature, right? So this bond become polar, as we can say that, see that, right? As we can see that. How? Because X is in a halogen, and we know that halogen is a more electronegative. Halogen is what? Halogen is more electronegative than carbon. So they have a strong tendency to take the electron of the carbon. And this will become partial negative charge. And due to the loss of electron, carbon become partial positive charge. So the carbon atom bears a partial positive charge and the halogen atom bears a partial negative charge. Okay. Now, so these all are the chemical properties of the alkyl halide. And now let's see the physical properties of some alkyl halide. So lower alkyl halide generally CH3F, CH3Cl, CH3Br, CH2 5Cl are gases at the room temperature. So lower alkyl halide means if I'm talking about the methane, ethane, or maybe propane, but it's very difficult. So only consider up to the methane and ethane. So these lower alkyl halide are gases at room temperature, right? So they are gases at room temperature. The other alkyl halide containing up to C18 and liquid having high boiling points, and haloalkanes and haloarenes are moderately polar molecules, right? Moderately polar molecules mean what, beta? So they having both positive and negative, right? So still they are immiscible in water. So being polar, because we know that polar like dissolve like. So the alkyl halide being polar because CX they having the polar charge due to the positive and negative charge on this. But even because of even after being polar in nature, the alkyl halides are not soluble in water. Can anyone tell me the reason for this? Anyone? Yes, beta. Anyone wants to say anything about this? Because we know that now, like dissolve like means if something is in something which is polar, they dissolve in polar, and water is a polar molecule. So for this purpose, we can say that now, कि water being polar, they are supposed to be dissolved in water because water is also polar and alkyl halide is also polar. But why alkyl halide are insoluble in water? Can anyone explain me? Anyone wants to say anything? कोई कुछ भी बोलना चाहता है इस पे? Right. So always remember this, beta, because alkyl halide is due to their inability to form hydrogen bond with the water molecule. Right. So they have a no tendency, no inability, or we say zero tendency or inability to form hydrogen bond with the water molecule. Right. Now the melting and boiling points of haloalkanes and haloarenes are higher than those of the parent hydrocarbon like alkane, alkene, alkyne. But if we're talking about the boiling and melting point of alcohol or later going chapter like carboxylic acid, they show more than alkyl halide. So now, just now I'm just comparing the boiling point of alkyl halide with the alkene. So we can say that the boiling point and the melting point of alkyl halide is more than that of alkene, right? Why this is? Is there a specific reason for this? Yes, we have a specific reason for this. The first is the greater molecular mass and hence the greater magnitude. So we know that the boiling point, this term depend upon the magnitude of the force, and van der Waals force is one of them, which depend upon the magnitude, right? So if someone having a more magnitude, they having a more boiling point. So basically, the boiling and boiling point is of the haloalkane are more. Why they are more, beta? Because why? Because they having more molecular masses as compared to the alkane, right? So the greater molecular masses and hence greater magnitude of the van der Waals forces of attraction in halo compound than it is in parent carbon. Or we say the existence of intermolecular dipole-dipole interaction as shown below. So this too might be the reason. So we can say that these are the boiling point of the haloalkane and haloarene that we have. Right. For example, if I'm talking about the CS3X or C25X, C6H5H, so here we have a XNH 111.5, X and F194.6. So these all are the boiling point, right? So if I'm talking about the XH, if I'm talking about the XF, XCl, XBr, and XI, so as we can say that at the molecular mass being increases, this also increases. Okay, ये समझ आ गया सबको? Now, all monohalobenzene are liquid at room temperature, and among dihalobenzene, the para isomer have the highest melting point. It is due to the greater symmetricity, right? So always remember this thing. Out of this para, meta, and ortho, the para being is more symmetric, and that's called the better parking of the molecule in the para isomer. If I'm talking about the chloro halogenation of a chlorobenzene at the ortho, meta, and at the para position. So highest melting point they show at the para position because it is due to the greater symmetry that cause a better packing of the molecule in the para isomer. Right. So this is all about the method of preparation and the physical properties of the alkyl halide. Right. So in the next class, because time is already up, so in the next class, we are going to, that is from tomorrow class, we are going to solve numerical and also try to cover the chemical properties in a short way and try to solve much numerical so that you were able to understand or grab the concept and try to solve question related to this. So till now, anyone having any kind of doubt, you can raise your hand or you can just unmute yourself or in chat box, you can ask anything, right? Tell anything you face difficulties so far. Alkyl halide is completed in your school or not? I'm asking this question in the beginning also. Whether this chapter is completed or it's still pending in your school. I'm talking about in your school. Which chapter is currently going on in chemistry? Hmm? No? Chalo. So this is all about the today class. हमने इसमें केमिकल प्रॉपर्टीज थोड़ा सा पढ़ा, पूरा नहीं किया. और हमने फिजिकल प्रॉपर्टी, मेथड ऑफ प्रिपरेशन ऑफ अल्काइल हैलाइड, अराइल हैलाइड, and some very important method of preparation of aromatic halide उसको भी हमने cover किया, like Gutterman, Sandmeyer. So these all play a very important role. And no, someone text me. Can you repeat? Iodization. Yeah. But basically, what do you mean by iodization now? In iodization, let me go back to the iodization. Yeah, here we can also see that in iodination, beta, iodination is what? Iodination just like a chlorination and bromination. But when we treat benzene or CH4 with I2, then iodobenzene will form along with the HI is also formed. Now this HI being reducing in nature, right? This HI being reducing in nature, so they make this reaction reversible. Right. Due to the formation of this HI, this reaction becomes reversible in nature. So we have to add an oxidizing agent. Why? Because this oxidizing agent can convert this HI to H2 and I2. So there is no formation of HI. So iodination is reversible in nature. We won't say that this reaction is not possible. This reaction is possible, but the reaction becomes reversible. And if you want to stop this reversibility or make this irreversible, you have to add an oxidizing agent like HiO3. Because what HiO3 do now, this HiO3 react with HI to form I2 and H2. I hope your doubt is clear. Clear, eh? ओके. सो चलो, लेट्स एंड दिस क्लास टुडे. और तुम ध्यान से पढ़ो इसको, एक बार और अच्छे से रिवाइज करो. कल हम लोग इस पे न्यूमेरिकल्स करने वाले हैं, राइट? ओके बेटा, टेक केयर.